Thursday without Franco today. Franco is with a customer today. He's doing it tough in the Barossa, looking after the Royal Flying Doctors. We send our thoughts out to him. Hopefully it's not raining. And today we've got Scott. I think Scott was on last week or the week before, I understand as well. So Scott's becoming a bit of a regular feature on Thursday with Franco's. And today we're going to be talking Ssl and TLS migration. And I'm sure we'll share the blog that Scott's created, but he's now going to take you through his slides and tell you all about TLS migration. Take it away, Scotty.
Awesome. Thanks, Jason. Good morning, everybody. And that's correct. I am going to be talking about TLS migration. I should have changed this title here to be Thursdays with Jason, but I left it with Franco.
We should have a warning, shouldn't we, Scott? This is going to be a little bit more technical than talking about Apex today.
I will try and keep it business focused. I think this is a really interesting topic. And I'll give everybody a little bit of background while I show this wonderful slide, because I'm sure everyone can probably resonate with this one. At some point or another, they have seen this type of error message. I have been involved in multiple TLS and SSL migrations, everything from going from SSL v2 to TLS v1, 1.1 when it was around, or even moving minor versions from TLS version 1 to 1.2. What I've shown on here is it's a bit of tongue in cheek, right? This is basically saying at some point, TLS will bite you, whether you're a business user, whether you're a consumer, whether you're an enterprise or a small, medium business. It is actually really important to ensure that you have strong SSL and TLS versions. But before I dig into exactly what it is, I will cover off what SSL and TLS is.
Thank you.
So SSL stands for the Secure Sockets Layer, and TLS stands for Transport Layer Security. Essentially, it basically provides the confidentiality and it ensures the privacy of our information that we send over the internet. So when you go to your banking website, when you browse Facebook, it's hard to find it now, but back in the day, there used to be giant big green padlocks in your web browser bar. And that meant
didn't there? That's right.
And now they've kind of hidden it for a range of reasons, mostly psychological around if it's green, different browsers had some green and some red and some yellow at different times and people get confused. So they've basically, most browsers now just say the site is secure or it's not. So people aren't confused when they switch from an Edge to a Firefox or whatever. So TLS is the protocol that is to replace SSL. If you are still using SSL v3, you're going to have a range of problems. It is very broken, it has a lot of security vulnerabilities, and TLS now supersedes that. So currently we're up to TLS version 1.3. Obviously we have version 1.0, version 1.1, 1.2, 1.3. They are very similar, or they essentially are the same protocol, but there are different sub versions of that. We call them different ciphers that you can enable to essentially allow you to perform different things to different levels to different cryptographic strengths. I won't go into too much more about the two different versions because I'm here to talk about the migration and how it applies to your business. But it is important to note that there are multiple organizations out there, and I've just picked the first 5 that came to mind. There are going to be a lot more that actually mandate the minimum standard that is required for TLS versions. Note that they don't cover SSL anymore, so SSL is well and truly gone.
And that's interesting because I wonder if most people know that, Scott, actually.
Yeah, well, you can still enable it. To be fair, when I was setting up this demo, I struggled to try and find a Linux distribution that still had SSL v3 protocols that I could use, which is a good sign. But I guess, yeah, certain workloads might still use it. But hopefully, if we follow this procedure, we'll be able to get to a point where we can move people off those legacy versions or even the earlier versions of TLS. So PCI DSS up here, so that's the Payment Card Industry Data Security Standard. So the standard that the card schemes, so Visa, MasterCard, Diners, Amex, put out to the payment card industry, transaction processors, banks, merchants, to say you have to use a specific version. And currently it's 1.1, and they're hoping to push to 1.3 by 2024. So that's actually quite a big jump, and we've seen that they've had to actually delay it because people can't do migrations. The other interesting one here as well is that most US government agencies have mandated a 1.0 for TLS be dropped, and that they should support TLS 1.3 from 1st of January 2024, which is also a very ambitious goal given the size of the internet running around the globe. So just an interesting point there, that you need to keep up with your TLS migrations, and you need to make sure that you're actually deprecating the old versions, and that you're able to support newer versions in your application stack.
I mean, and this is why this is important, and this is why we're going through this whole explaining the migration, because you do need to keep up, and there will be those timelines where the other versions will drop off and then your sites will stop working.
Correct. And I've got some really good stories about that, which I'll share very shortly. But before I do, I know I said I wasn't going to get too down in the weeds of how TLS and SSL work. This is the best diagram I have to explain it, and it kind of highlights exactly why there's a problem. Right, so on the left here, we have the OSI model. It's the 7 different layers, pretty sure there's 7, yep. And on the right, we have the TCP IP model. So basically, the bits in yellow represent TLS or SSL. They do change a little bit depending on the version, but the key thing to take away here is that we typically operate at the application level. So you deploy a website, you deploy a web server, you deploy an FTP server. It doesn't really matter what it is, a web server, a mail server, that's all running at the top layer here. When we start talking about TLS, it's actually at the layer below it. So what does that actually mean, and why is that important? If you've got 2 clients that are connecting, one that is supported, so say you've got you want to connect on TLS 1.2, and then you've got another customer that's trying to connect on TLS 1.0, but you don't support 1.0 anymore because you've migrated away. The first user will connect fine because this layer here works in the yellow. The second user who's trying to connect on a version which isn't supported anymore because you somehow turned it off, it terminates. The connection terminates here. So you don't see any logs. You don't see anything at all. The user, if we go back to that first slide, is going to see something like connection failed, TCP reset, things are broken. They're going to be really frustrated and angry. You as the business aren't even going to know that someone had a problem. And the first you're ever going to hear about it is when people ring up and start complaining. So this is why it's very important to take migration seriously, and you need to have a good rigor around how you do it. Otherwise, you can end up in a situation where things could be going wrong and you don't even know about it.
I suppose that's provided the customer's using an up-to-date browser that will only use the newer versions, and then your site is using an older. So it's basically protecting them from nasty sites, yeah?
Well, yeah.
Or sites that aren't as secure as they should be.
It's typically the requirements that are put on you as the business that say, okay, we need to support those standards, PCI, whatever it might be, HIPAA, NIST, whatever, to say we can only support these versions because of the criticality or the vulnerabilities that exist. So yes, if you are supporting weaker, older versions, then yes, you're putting everybody's data at risk.
Yeah, which is not good. Yeah, especially in lights of stories that have come out recently. We want to make sure that we're, without mentioning any names, we want to make sure we're doing our best to, keep up with the latest versions and protect our customer and their data, as to the best of our abilities, basically.
Yeah, probably the most notable one that comes to mind is Heartbleed. Basically a poor implementation of SSL, and this is kind of my first line here. Why do we even need to consider to migrate things? And that's because over time libraries get outdated, new vulnerabilities are discovered. Some of them are really critical, like just full memory corruption and memory disclosure to untrusted authenticated users. In terms of the Heartbleed vulnerability, that then basically meant complete compromise of systems from a pretty anonymous vulnerability.
This can also incur a cost for some customers. For example, the customer I was working with, it was a warehouse management application, and they had old warehouses with handheld devices that they used for scanning products and things like that, which they had to actually manually buy new ones. They didn't support the new TLS.
Yeah, those older machines, as you say, they were sort of locked into older versions, weren't they, Sam? And that was, as you say, that was a problem that they didn't know they were having, basically, or that they were vulnerable.
Correct.
Correct. And so you either have to consider for that. And that's why my first line item here is that most people or businesses don't understand that legacy things. I worked for a company where we had a merchant that was doing payments, credit card payments for car washes in embedded Windows XP. And those basically weren't able to support anything later than SSL v3, I think at the time, with what was installed. So you're right, you have to consider, well, can we even support later versions? And it is a balance, but you just need to consider, is it possible to upgrade? Are there other alternatives that you can take into account here? The other big key one is APIs, probably to your point, Sam, is that they're not a web browser, not a just easily updatable software. In the most use cases where people have an up-to-date OS and they're using an up-to-date browser, Chrome, Edge, Firefox, whatever, they're going to be receiving regular updates, which means that they don't have to worry about patching cryptographic libraries. They're just going to be able to support TLS 1.3. APIs, on the other hand, are typically built, they're sometimes compiled, they're then installed on a server somewhere. That server ecosystem can be huge depending on the size of your organization. And often those are basically tied to specific versions of perhaps Java or specific libraries of OpenSSL and certain versions of the Linux operating system. And so upgrading that actually takes a long time. But what it actually means is you're actually limited to what protocol versions you can actually use, right? So you might have an API that's running somewhere that you don't know about that's only able to talk TLS 1.0 because it was built in that era, and you haven't updated it, for example. And that's quite a big one because those aren't users of the system, those are machines. So something's going to break, the machine's going to stop working, the process is going to fail, someone's going to have to do a huge investigation to find out that your APU, as a provider of an API, turned off a version, we didn't know about it. Gets very difficult and messy.
And that can be loss. I mean, that could be loss of business right there, couldn't it, in transactions? So, I mean, that's going to be costly. Again, to what Sam was saying, you know, it can be a large cost.
Yeah, last thing you want to find out is that, you know, you're going cut over a production environment and you find out these machines aren't working because when they when they were doing the testing, they were using virtual machines.
Right. It was all fine in the virtual world. It was just when they went to reality.
And I've seen it many times where people go, oh, it's not going to be a problem. We've told everyone they should upgrade. And great, we've turned it off. And then we end up in a situation, which is kind of my last points here, I'll summarize, is that we end up having to roll it back because the communications weren't clear. We didn't have up-to-date communications of who to contact. We didn't know the lead time for businesses to change. We told them 6 months ago, but it's going to take them a year. There's so many different reasons why. And probably the biggest one down here that's quite funny is actually apathy. You can tell someone they need to do something and they're just going to, I'll do it later, do it later, do it later. Bit like multi-factor authentication on your user accounts. People just go, I'll do it later, and then they get their account hacked and then they turn it on. It's basically that type of
only I done MFA sooner, yes.
But so if we take all of those things into account, realistically, the questions you need to ask or organizations need to ask is if they're going to go through this migration, and they should probably incorporate it as part of their ops plan. If you're going to turn off a specific version, what percentage of my customers will be impacted? Remembering that if we go back to my earlier slide here, remember if we turn it off, we're not going to have any logs, right? So how do you actually know is the first thing. Of those customers, are any of those key accounts, right? So what are we actually talking about there? We're talking about saying, well, I know Jason's using TLS 1.0 and he spends $10 million a year with us. But I know Sally over here maybe spend $50,000, but I consider both of them key accounts, right? So I need to be able to understand and derive those metrics. How fast the customers? Yep, sorry.
I was just going to say, but all of a sudden, if your bottom line drops because I can't get through to buy things via your API, and I'm the $10 million customer a year, that's going to affect your bottom line somewhat, isn't it?
Oh, most definitely. And I can say when I've been through this personally, with a wider organization, yes, people get very angry when they can't make payments.
But I think this is the bit, as you say, you know, I said at the start this was all going to be techie, and we would keep it more business focused. And it was great to have Sam tell us about his experience too there. But this is the thing, bringing it back to reality about this is, yes, you know, you want to be secure, but you also need to make sure that you're not dropping off some of your best customers, and or at least having the ability to go and say to them, well, we need to move you all up together so they still get to use the service, we don't lose their revenue, and everyone's more secure.
Yes, correct. And to that point, yeah, you basically need to know, once you start telling people about it, how fast are they migrating? How fast are their systems now using a stronger version, which you're going to support and not one that you're going to deprecate? And also, is there stuff we don't actually care about at all? Like, is there traffic that we're not concerned about because it's bot traffic, or it's coming from a country which we don't serve, or something like that? So those are the kind of the key questions that I would ask if I was to go through a migration myself. And what I'd actually be looking for is, how could I build a solution to answer these questions for me? And I have.
How would we do that, Scott?
How would we do that? So the simplest way to do it, and I did look at several different options here. I've chosen to use OpenResty, and I'll explain what that is in a second. Some of you are probably thinking, why couldn't we use the network tap, which is a new feature in OCI? And it's because we need the SSL certificate to pass, we need the contents to be decrypted, and we actually need the content inside the HTTP request. And I'll explain why that's important shortly. So we couldn't use the network tap. OpenResty is really cool. It's based on Nginx. It's got a terrible name, I think, but basically it runs what they call LuaJet. So for those of you that are familiar with scripting, Lua is a scripting language. It's very fast. OpenResty has the ability to write Lua scripts, which can be hooked in at different points in the web stack. So you can say, okay, when something comes in, and in my case, when a web request comes in, parse the request body and extract some information like the username or the API username and the client IP address. So that kind of information is going to allow me to answer those questions, and I'll show you what that looks like shortly. So that actually acts as my load balancer in my public subnet. And all I do is actually forward all the requests on to my load balancer in my private subnet. So there really is no difference to what you would have set up for a normal web server deployment. And that's quite important, because you don't want to have to re-architect your environment to make this work. You just want to be able to put in a proxy, basically, is all this is working as a reverse proxy in front of your load balancer. You could put your load balancer in the public subnet as well if you weren't wanting to move it into a private subnet, but it basically everything else about your workload stays the same. It goes through an internet gateway. You load your SSL certificate on OpenResty. It's Nginx, really straightforward. And then all we're doing is using LuaJet to write to some TLS logs, which are then going.
Sorry, just to ask one question as a techie here. That won't become a bottleneck and cause performance if you're running everything through that OpenResty?
So this is a compute instance. So you need to pick an appropriate shape that's going to be able to support that traffic, the same as you would with a load balancer.
Yeah. Okay.
And the logging is the way that it's done is that it's not when it makes a log call, it's actually really fast as well. There is a better way to explain that and how it does the handling of threads. But essentially, there should be no performance impact here. But you could once again test that. You could send it a whole bunch of traffic and see how it's behaving. The key bit is just make sure your compute shape handles CPU.
Absolutely.
Network.
Understanding that the larger compute shapes have larger bandwidth for the network connections as well. If just so people understand what we're talking about there, that's how you get the larger pipes, basically, by having those larger shapes.
Yeah, and that's actually it. So the key bit here is that the only thing I'm having to run that's not an OCI native service is OpenResty on an Oracle Linux 8 VM, which is the only thing I've got to change. You can
make that highly available somehow. Can you have two running?
Yes, you definitely could. Yep.
Active passive.
Thank you, Sam. I was waiting for someone to ask that.
Yeah, so if you really wanted to do it, you could put like a network load balancer in front of it. There's lots of different ways. I was trying to keep it simple. If you are going to go through a migration, I'm more than happy to show you how to set this up in a HA config.
Glad to see Sam, the architect, is always thinking about HA.
Yep, and it's a good thing. You do have to think about it for sure.
Yeah,
I will swap over here. I'm going to run a demo now and explain how this works. But before I do, we've got some curl commands because this is going to explain what you're actually seeing. It's very hard for me to build a web application in time, so I'm basically using curl to simulate API calls and web calls to my OpenResty instance. So my first one here is basically a JSON API. So this basically says post to migration.deflectingme, which is the domain I'm using, /auth, and I'm going to use TLS version 1.3. It's going to be a JSON API, and this U just adds a basic authorization header. Base64 encodes it, but basically it's a username Scott, password. Obviously, this would be a real user's password. Got the same for Jason, but he's going to use TLS 1.2. Jason's also using TLS 1.1. Jackson's using 1.0. Sally's using 1.0 here as well. So those are all my API calls. So this basically simulates the different browser versions that are supported. Because the client initiates the connection, the client's going to say, I can connect on 0, 1, 2, and 3. And you'll see that shortly. And these second ones down here simulate a website login, right? So API logins at the top and form post logins at the bottom. And you could change this as well. So depending on your application, what these field names are called, you can update the script. And the script, I'll show you the link to that shortly, which explains how you can pull out different variables. So if you weren't using username, for example, here, it was uname or name, you could do that as well.
So this is to simulate either a web browser or an API coming in, doing a call using one of those different versions of TLS, is it?
Correct.
Right,
yeah,
okay.
Exactly. So you can see here, we've got some different users down here as well. And I'm going to run those just real
I don't know
quick.
if I was dumbing that down for me or the audience there. If I helped anyone, I'm glad I did.
So we're going to make some calls there. Now I need to find my web browser.
Oh,
right.
Yes.
Here we go. So
it reminds
really
me of an
basically,
IT crowd episode, but I won't go into that now.
So if I go to my migration, so if I go here, right, so this is the web server behind my OpenResty instance, just a basic web server. So that's essentially what's running, and that's this one here, right? But I've got my OpenResty instance, and that's actually what we're connecting to. In here, I could show you the Lua code, but I won't because it looks pretty terrible. It's not the nicest thing to look at.
Yeah, keeping it high level, Scott.
if anyone's interested in having a look at that, they definitely can. So the way
that's in the blog post, is it?
It is. All the code's in the blog post.
Okay.
There's GitHub source code there as well. So I collect this log. So my Lua script writes to my TLS log file, and I'm using the Oracle Unified Monitoring Agent to retrieve that in JSON format and then load it into my log group. So I might have to go back.
So using native OCI services, this is excellent.
I am, yes.
Yeah.
So
how good is that? Yeah.
And if we look down here, make it any smaller. On the right-hand side here, you see some log entries. So these are the fields that I'm capturing from my Lua script in OpenResty to the local file system into logging. I've got my IP address here, the host name, the method, the time, that's Unix time, the TLS version.
And this is the information that Resty is capturing and dropping into that log, and then you're processing it through the logging, yeah?
Correct. That's exactly right.
Excellent.
The user agent, the username, and the tail path. Note here that I'm not actually capturing the password, and that's a very important thing to note. You don't want capturing username, probably okay. It doesn't contain any authentication information. It just contains the name of the account or other user ID field that you want to use. So you do need to make sure you only capture the fields that you absolutely need. If you're capturing passwords, you're going to end up with passwords in your logs, and that's a world of
suggest
pain.
you can capture passwords?
100% you can.
Absolutely, you
yes.
can. Yeah.
Nice.
Yes. So when OpenResty runs,
Forget you
the
heard
full,
that, Stu.
the full web request is intercepted, and it can read the full payload body. But in the script, and I could show you if anyone's interested, where I'm actually I'm explicitly selecting the fields that I want. So I'm only selecting the username from the basic authentication header, and I'm only selecting the username from the form post. And that's super important, because I worked in places before where people have got usernames and passwords and all sorts of stuff in logs, and that's a real pain.
But the thing is here is this is allowing you to gauge what your customers are using as a TLS version, to know the impact. That if you suddenly say, I'm going to be super secure and only allow the latest version, you've got some idea of who you're going to be losing or who you need to get in touch with to say, this is going to happen and you may want to update your security.
Yes, that's exactly right. And it's also that you wouldn't want to probably run this all the time. You would drop this in as a solution, run it for a bit, delete it, remove the logs, life's good. So that's the less exciting view of the world, which is data in logging. If we now go to logging analytics, which is
pretty.
one of my favorite things.
It's a great, I like this. This is very good. We need to do a whole thing on this too, I think.
I've selected 8 hours. Basically, I've created a few widgets. It's nothing fancy.
What are we looking at here, Scott, for people that may not know what this is?
So this is a logging analytics dashboard. So I've now taken my logs from logging. I've now imported them into, and I'll show everyone what that looks like just quickly right here.
Another one of our lovely native services in OCI, yeah?
It is, yes. So it allows me to do more advanced things like create graphs, perform analysis, create events and alerts and all that kind of stuff based on data that I ingest. And so this is essentially the same log, which you see in logging, is now in logging analytics. And it's got all the information here. So the version, one of the cool things that I actually have done as well is based on my IP address, I can actually use geolocation to create me this beautiful map, which is this map here. So you can see all my requests have come from Melbourne, which is where I'm based. Interestingly, though, IP addresses have been pinging my website from all over the globe, which is an interesting point. If we look over here, we can look at the distribution of different versions. So we can see, okay, how much TLS 1.3 traffic have I got? How much 1.2 traffic have I got? We can also look at it based on user agents. So we can say, we know that people are running old versions of Edge or Mozilla or Chrome or whatever it might be. Or we could say, we know it's mostly curl, right? Because I'm running curl commands. So we can say, it's an API, or it's a machine making these calls. So it now tells me, is this a user problem or is this a machine to machine problem? Also,
sort of goes back to Sam's use case where he would have been able to see that there was a whole bunch of handheld machines that were calling on a certain version. So he wouldn't, that way that customer would have known about their problem ahead of time.
Yes, definitely. And you'd see a majority. Like often we don't see a lot of web browsers in here. It's mostly APIs these days. But that's not to say I have worked in some places or seen some customers where they are running like legacy versions of Windows for whatever reason. And you would see those here.
Nostalgia. Some people just like to use Windows 95. You know how it is.
I actually set it up the other day.
Neeson bouncing his IP address around the world, isn't it?
True.
I'll find you, Stu. I know where you are.
And probably the last bit here, which was that question of how do you tie users to the problem? And that is using this table. I'm just showing it at a table, but you could export this into a CSV and then import it into a marketing system and communicate with people or call them. But basically, you know, at what time, what path they requested. So I know that my API auths on /auth. I've retrieved only the API username here, and I know what version it is, and I know their IP address. Similarly, if we look down, we can see our users to our /login, which is our website, and we know that it's Whitney, James, and Nikki. And then some more Jason in here. You need to update your TLS version, Jason.
Yeah, sorry, man. Yeah, I'm slack as. It's user apathy, obviously.
So that basically allows us to
At least
answer
I'm
all
not
of those
not
questions.
as bad as your puppy though. Jackson's on a really old version. He needs to update his browser.
Oh, he does. He does. He's playing with Mr. Pig at the moment. And that's essentially all I'm going to show. I'm not going to dig into too much of how the actual scripts work. If people are interested in running this for themselves, the full instructions are here. Where is?
But I think even as a separate, thought that's really cool that you can basically ingest logs and then drop them into a dashboard, and then quite quickly, was that a very easy process to build the analytics out of that from those logs coming in?
Once you've done it a couple of times, yes, it's really
it's
easy.
Pretty straight, yeah. Because that looks quite impressive, like what you've managed to build there and pull out of those logs. It's quite as I say, there's some quite powerful tools. There's a lot of hidden gems, I'd like to think, inside OCI, and I know I go in and discover all sorts of things. Like the new desktops we've been testing out this week, things like that are coming. There's lots of amazing things coming in OCI, and a lot of them are already there as well. It's just a matter of knowing where they are. Maybe it's time for a test drive on logging.
We could definitely do one on logging.
Yeah, talk to your local friendly ringmaster or technical person to find out.
That's right. So we've answered these questions. Yeah, we've basically answered these questions. So we know what percentage of my customers will be impacted if we turn off a specific version. We're going to know if they're key accounts or not. That might impact our decision to delay things or give them another route or a workaround. We're going to be able to track burn down over time. You can just say, okay, and you could do comparisons in logging analytics. So you can say, show me this date range compared to that date range. So we'll be able to actually track, are we on target for turning off old versions on a particular date or not? What do we have to do to get it back on track? And we also know, like, all of that stuff outside Australia, I'm not interested in. That's just people scanning my site for no reason.
Right.
So I'm not worried. And I'll leave people with a couple of project resources. So there is a blog, my blog, on blogs.oracle.com that explains how you can set this up. It explains how to use SSL certificates and things. And I also have my source code for the whole solution that everyone can download and have a look at, including the dashboards. So you can download the parsers and install it and get the logs into logging analytics and create beautiful dashboards with it. And just some of the other resources that I've used here as well. So
the blog you mentioned, that takes you through basically effectively creating what you've just been talking about today, yeah?
It does, yes. The only thing that I will mention is I wrote this a little while ago, back in August. And so the suggestion around how to create certificates down here, wherever it talks about it, it only generates OCI certificates. So it generates private certificates. So you will get a certificate error, but that's not here nor there. If you don't want to have a certificate error, you can use a public certificate or use Let's Encrypt.
I wonder if there's a new service that we could, a blog post that may be coming that would help you make those certificates. Do you know of one, Scott?
There is. I have actually built another working demo, I'd like to call it. I'm actually doing a bit more work on it now, but essentially it allows you to generate Let's Encrypt certificates using serverless infrastructure. It uses Vault, certificate service, secrets. What else does it use? Lots of lovely
OCI native services by the sounds of it, which is great.
It's all native, and you can use it to generate normal certs, subject alternative name certs, wildcard certs. You can choose to deploy those in any region as well. So you can say, oh, I've got my function in Sydney, but I've got vaults in America, Singapore, France, and those keys need to remain in those countries. So it can do all of those things as well.
Right. That sounds wonderful. That sounds like another Thursday with Franco session coming soon, I'd imagine, once that's all nailed down and ready to go. That sounds like a wonderful thing. Okay.
Awesome.
I think that is awesome. That's wonderful. And I hope people got a lot out of that and understand that this is something that's, quite relevant, and, certainly to businesses, they need to make sure, they are protecting and moving up and keeping with the latest versions, but they also need to understand that that's not going to break, you know, their business, because they've got a lot of customers that are using older, you know, less secure versions of TLS. And as we said, as we highlighted, you know, you don't want to stop supporting that and then find that you lose a large amount of your traffic and your business. So to make sure you're aware of what your customers are actually doing from a TLS point of view becomes quite relevant.